Hello everyone, this is our first lesson in Unit 4, Bonding. We have a bookwork associated with this lesson, questions 1 through 5 on page 99, and we will have just completed the Unit 3 look back. The aim today is what is a chemical bond and why do they form? What I want you guys to do is to get the do now copied down on a separate piece of paper. So take a moment right now, pause the video, and copy down these do now questions because we're going to answer them in class tomorrow. I really do want to see that you have those copied down, so make sure you have those. All right, the mini lesson. In terms of electron configurations, what do you think it means for an atom to be stable or unstable, and why do you say that? So I can answer this. The reason why an atom would be considered stable or unstable in terms of electron configurations is based on the octet or the valence shell. So if the octet is full, or if the valence shell is full, we consider that electron configuration to be stable. And the reason why we consider it stable is because once that valence shell is full, it no longer changes. On the contrary, if an atom does not have a full valence shell and is therefore considered unstable, we consider it unstable because we expect changes to occur from there. But for those atoms that are unstable, not all hope is lost. All atoms can become stable if they gain or lose electrons in strategic ways. So what can atoms do in order to become stable? They can gain or lose electrons. If you look up magnesium on the periodic table, you'll find that it does have 2 electrons in its valence shell, which means that it is actually unstable. And in order for it to become stable, it must lose 2 electrons. I'm asking you to consider now if there's an element that you know of that could easily accept those 2 electrons in a way that's mutually beneficial for both magnesium and the other element. And then once you have an element in mind, just think about why you chose that element. So pause the video and look on the periodic table for assistance. So one element that a lot of people choose in answering this question is oxygen. And another element that a lot of people choose is sulfur. And what those two have in common is that they each have 6 electrons in their valence shell. And if they have 6, then they want to gain 2, and they could easily accept 2 electrons from magnesium. And in that case, both magnesium and the other element would become ions, but they would also be forming what we call a bond. So when the 2 electrons from magnesium travel over to the oxygen atom, both the magnesium and the oxygen atom become ions. Magnesium becomes a positive 2 ion, and oxygen would become a negative 2 ion, but they also now have this bond between them. We would call that an ionic bond, but we'll deal with all those details later. Right now, I just want you to consider what potential energy is. And potential energy is it's an ability to do work, or you can think of it as stored energy. And the potential energy of atoms can definitely change, meaning that the amount of energy that they have stored doesn't have to be constant at all times. In fact, that's where chemical reactions come from, especially the most memorable ones, the ones that produce fire, flame, light, heat. All of those things I just described are different ways of energy changing, specifically energy being released. So in those cases, when you have a fire or light or heat or sound being released by a chemical reaction, what you also have is stored energy that's being spent. It's being released. And that's proof that the potential energy of an atom can change. So I wrote down the 2 ways that I know are heat loss, that's energy being lost, so I know that there are changes in energy happening. But also I mentioned that When you put something through a chemical reaction and then it stops, when that reaction stops, it's because it's no longer going through any changes, and we just said that that means that it's stable. So stability is increasing over the course of a chemical reaction, especially if the energy is decreasing. So I wrote down stability increases when potential energy decreases, or you could think of it as stability increases when heat is lost. Okay, so there are two types of chemical reactions, endothermic and exothermic. One of these processes involves energy being added to a substance, and the other involves the release of energy by a chemical process. Which is which? Pause the video and think about which one you think is which. Do you think endothermic means energy released or energy absorbed? And do you think exothermic means energy released or energy absorbed? All right, and the last thing I want to cover in this video is the potential energy diagram that would cover an atom losing energy, just like we've been discussing. So basically on this axis, on the y-axis, we're going to have potential energy. And on the x-axis, we can call it reaction coordinate, or we could call it time. But what we were discussing was that we have an element that is losing energy over time. So what I definitely want to show that. I want to show that at the beginning, before the reaction has occurred, you have some elements with a certain amount of energy. And after the reaction has occurred, you have those elements again, but they've rearranged, they've formed a new substance, and they have much lower potential energy. And you just need to connect the two. But there is a slight trick to this, which is that generally before the reaction starts to go, you have to heat it up or something. So you have to give it a little bit of extra energy. So you see the energy rise before it falls down to its new level. So basically you have a hump in the middle, but a big dip at the end. And the guys at the beginning, which we'll call reactants, have much more energy than the ones at the end, which we'll call products. Okay, so we reached the end of the lesson. I just want to make sure that you guys also copy down this pair up on that same piece of paper where you copied down your do now, so it's like a separate classwork paper. And also copy down this summary question down here at the very bottom, and you'll be good for class tomorrow. Thanks for listening. Bye-bye.